So in 4-4, we are going to be reviewing over some main concepts that you learned back in Algebra 1 with factoring. The most important step that we have to take before we do that, though, is remembering the key concept of the factoring concepts, and that is finding the GCF, or the greatest common factor. And there's a couple of different ways that you can approach this. If you're looking at your numbers, you're specifically going to be looking for, well, what can I divide all of my numbers by? Specifically, what is the highest number that I can divide all of my numbers? Once you have figured out that particular number, then you can look at your variables, okay? And again, it's the same idea as your variables, but sometimes it's a little abstract to think about because we are used to looking at 2s and 3s and 4s, but we're not exactly used to looking at x's and y's and z's. And so in this case, what you want to ask yourself is, instead of what is the largest x you can divide by, you can ask yourself, well, what is the most of a variable that I can take out? Or what's the highest number of variables I can take out of a particular problem of each term. There we go, of each term. Okay, and typically it's going to be represented by the smallest variable, and I'll show you what that means in a second. And then step 3 says, you divide each term by coefficients and you subtract your exponents for all of your variables. So if we look at that first example, 24x to the 5th times y to the 4th minus 60x to the 7th times y, we can ask ourselves the first question, well, what is the largest number that I can divide all of my terms by? I have 24 and 60. The highest number that I can divide out of this is going to be 12, okay, because 24 divided by 12 is 2, and 60 divided by 12 is going to give me 5. Then I look at my variables, and I'm going to look at each one independently. So I'm going to focus on my x's first. So in the first portion, I have x to the 5th, and in the second portion, I have x to the 7th. And so my smallest of those two would be x to the 5th. So if you want, you could actually, and I'm a visual person, so the first couple times I did this, I tried to make sure that I wrote all this out so that everybody could see. But in the first term I have 5 x's and I have 4 y's, and in the second term I have 7 x's and 1 y. Let's get that. There it is. There's a y. So I can even count, okay, what is the most I can take out of each one of them without going over. And so that's where I can see that I can take out 5 x's. So, and here's my smallest variable, so there we go. So this is going to be x to the 5th that I'm going to take out, and then I do the same process with y's, and it's actually a little bit easier because the first one has 4, and the second one has 1, so obviously the most I could take out of all of that is only 1, which is my smallest variable. So that'll be y, and then I put my parentheses and show, well, what would it be if I were to, in fact, divide out the GCF? So if I were to divide out with that first term, it would be 24 divided by 12, which I already said was 2, x to the 5th divided by x to the 5th. Well, anything over itself is 1, so that cancels out. And I would do the same process with the y to the 4th divided by y. The instructions say to subtract the exponents, so 4 minus 1 would be y to the 3rd. So then I'm going to do the same process again for my second term. I'm going to put my minus sign, and 60 divided by 12 gives me 5. X to the 7th power, take away 5, or divide by x to the 5th. That's going to give me x squared. And y over y, well, that just gives me, 1, which cancels out. And so I can say that I can end this particular GC, or taking out the GCF here. Again, if we focus on the visual aspect, from each term that I wrote out all of my x's and y's with each term I took away 5 x's. So I'm just going to box this in really fast and then cross it out at the top so we can clearly visually see that we have crossed out 5 x's on each side, okay, and 1 y. And now we can see what's left over. In the first term, I have 3 y's left over, and in the second term, I have 2 x's left over. And so the visual method is very nice. It helps us, make sure that we're doing this correctly. The other way that we can just double check that we're doing our GCF correct is by distributing it back in with the distributive property. If we end up with the exact same thing we started with, then we did it correctly. But if we end up with any sort of slight variation or just totally blatant incorrect number, then we know that we've made a mistake and we should go back and retry this. But if I were to distribute this, I would get 12 times 2, which is 24, x to the 5th times y to the 3rd, which would be y to the 4th. Okay, and that does in fact match what I have up there, minus 12 times 5, which gives me 60, x to the 5th times x squared is x to the 7th, and then y. So I did in fact end up with the same thing I started with. Same idea off to the right. We have 15, 75, and 5, so my GCF or my coefficients here, or what I can divide all these numbers by, is 5. Then I can focus on my variables, and I'm going to write this out really fast. A, B, A, B, and AB. So I just wrote this out really fast. And now it's easier for me to see that my GCF for A is just going to be A to the first power. And my GCF for B is just going to be to the first power, because that's the smallest variable I have out of all my terms. I have A squared, A to the 4th, and A. The smallest is A, so that's going to be my GCF. And then same thing with B. I have B to the 1st, B to the 1st, and B to the 1st. So my smallest is B to the 1st, so it's all the same. Now I'm going to show, well, what is my new polynomial going to be if I were to, in fact, factor out that GCF? So in the first one, 15 divided by 5, let me put my parenthesis. Actually, let me cross these out so we can see what we're going to end up with. We're taking out AB in each term, so this is what we should have left over. Okay, so here's my parenthesis. 15 divided by 5 gives me 3. A squared divided by A, that's subtracting your exponents. 2 minus 1 is 1. And even in the picture, even in the, not the picture, but let's focus on it right there. Even when I wrote all this out and I crossed out an AB in that first term, because I factored it out here, I have 1 A left over. Okay, so we can keep going. We can say that this is going to give me 3A plus 75 divided by 5 gives me 15. All right. Again, I can look up at my picture up here and I can say, okay, I had 4 A's. Take away 1, we have 3 left. So it'd be A to the 3rd. And then with the B, I only had 1 to begin with. So when I took it out, obviously, I have none left. So the next thing would be my minus sign, because I don't have a B in this case. 5 divided by 5 gives me 1. And then from here, I took out both my A's and my B's. They're completely gone. I took away, this is what the GCF means. It means I'm taking away an A and a B in each of my terms. And so I only had 1 of each in this particular term. So I am done with this portion, and I would say that this is my final answer. Okay? So again, if I wanted to distribute it back in, 5 times 3 is 15. A times A is A squared, and we don't have a B, so we'll carry that over. That does, in fact, match what we had to begin with. 5 times 15 is 75. A times A cubed is A to the 4th. B is just carried over, which does, in fact, match what we had up here. And then 5AB times the negative 1 is just negative 5AB, which matches. So I'm just making sure that we did this correctly. Beneath it, we have our examples, and these are actually a little bit easier. So in example 1.1a, which is over here on the left, my GCF, I don't really have a coefficient that I can divide all these by. I don't have that. But I do have a variable. I have x to the 3rd, x squared, and then x. So my smallest variable is x. So that is the most that I can take out. So I'll say my GCF is x, and then I'll divide it out. I'll end up with x squared minus 2x minus 24. All right, and then that is my answer. It doesn't ask me to factor anything else, so that's just my answer. For the one beneath it, before I even get started, I need to bring over that 25t. So I'm going to subtract it on both sides. Just note that these are not like terms, or it does not have any like terms. So we're just going to put it at the end and call it a day. All right, there's my 25t. And technically I could say it equals 0, but that's just excessive, so I'm not going to worry about that right now. Now that I have everything on the same side, I can go ahead and factor out my GCF. My GCF of this particular case is 5t. I have 5, 20, and 25. So the highest I could possibly divide by is a 5. So it'd be 5t. And so if I were to divide that and divide each term by 5t, I would end up with t squared plus 4t minus 5. And that is my answer. So going to example 1.2 on the right-hand side over here, same idea. We have 3p to the 5th minus 192p cubed. The highest number I can take out is a 3. And my smallest variable is that p cubed, so that has to be my GCF for the variable. And then I'm going to divide all of these items by it. 3 divided by 3 is just 1. P to the 5th divided by p to the 3rd is p squared minus, and 192 divided by 3 is actually a 64. And then p cubed over p cubed is just 1, or it cancels out. So this is my answer. Beneath that, same idea. First things first, let's focus on our coefficients. We have 2, 9, and 18. Well, this is unfortunately not very helpful because I have a lot of, there's just not a GCF for that. There just isn't. So now we're just going to focus on the variables. I can see that at the very end I have q to the 2nd power. So I start off with q to the 4th, q to the 3rd, and then q squared. This is my smallest variable, and so this ends up being my GCF. So that means everything inside, none of the numbers change, but the exponents do. So it would be 2q squared plus 9q minus 18. And that's my answer. So the next section is grouping. And grouping is a nice place to start when it comes to factoring because it builds on the GCF idea. So because we have 4 terms in grouping, what we're going to do first is we are going to sort of split this in half, if you will. So we're going to focus on the first 2, and then we'll focus on the second 2. And we're going to ask ourselves, what is the GCF of the first 2? Well, in the first 2, my coefficients, obviously I just have 1 and 2, so I don't have a GCF for my coefficients, but I do for my variables. It's going to be that x squared. So we'll end up with a times x plus 2. I just factored out that x squared. And then I'm going to focus on the second half. My GCF for the second half, I have 3 and 6, is going to be a positive 3, and it's important to bring that positive with it. And then if I were to divide that out, it would give me x plus 2. Now, because my parentheses are the same, I know that I did this correctly. In this section, if you are doing it and you end up with different parentheses, you've made a mistake. And you need to go back, double check your work, or double check your signs, or your division, or whatever you think you made a mistake on. But your parentheses should be equal in this particular case. And it's not that it should always be like that, because sometimes things are infactorable. But in this particular section, they are all factorable. So you need to go back and double check. So once we're done with that portion, we're going to rewrite it. And what we're going to do is, since the 2 parentheses are equal to each other, they are going to come together into the same parentheses. So it's going to just sort of morph together, if you will. And then the 2 GCFs, the 2 pieces that left, are going to create their own group. So we'll say x squared plus 3. And that is our answer. And that's the same process over and over again. So in example 2.1a, same idea, we're going to cut it in half. And the GCF for the first half is going to be 2x squared. That'll give me 2x minus 3. And the second half, our GCF is a positive 5. And that leaves us with a 2x minus 3. So we know we did it correctly because our parentheses are the same. So those get to morph together. And then the 2 pieces, that 2x squared and that positive 5, are going to come together and make their own group. All right. And really fast, what if they don't look like they're going to be equal to each other? So in example 2.2a, we're going to start off by separating it. The first to the GCF, I was going to call it GFA, I don't know why, but GCF of that is going to be x squared again. That'll give us x minus 2. And in the second half, I could factor out a 4, but if I factor out a 4, I'll end up with negative x plus 2, which is not the same as what I need. So I'm actually going to factor out a negative 4, and that's going to give me negative 4 divided by negative 4 is positive 1, or positive 1x. And then 8 divided by a negative 4 is a negative 2. So now they are equal to each other, they can morph together, and the two pieces here get to create their own group. Now in class, we went ahead and stopped here because I hadn't taught, or I hadn't, I guess if you will, refreshed your memory on what that next step was. But in actuality, we can take x squared minus 4, and we can factor this a little bit more. This is what we call a difference of squares. And so basically we would take the square root of each one. The square root of x squared is x, and square root of 4 is 2. And we would make one positive, x plus 2, and one negative, x minus 2. And then carry down the factor that was already there, that x minus 2. And so this would be our answer. And that's actually something that you're going to see in your homework for this section. There are a couple of times where you end up with a difference of squares. And because you have that difference of squares, the program and other things are going to expect you to factor it completely. So then probably the most common type of factoring that people remember are the normal trinomials. This is when you learned either the X method or the Diamond method or the X factor. It all means the same thing. I think in this particular school we focus on the X factor, so that's how I'm going to refer to it from here on out. But in this particular section, we're going to take our X factor, or excuse me, our terms, and put it in the X for the X factor. So I'm going to highlight this, and I'll do my X factor. I'll put 2 on top and negative 63 at the bottom, and then I'm just going to write the factors of 63. So we could have 1 in 63, or actually, a common problem that I noticed when I was teaching this was that a lot of people didn't understand what this circled sign here meant. If the sign in front of your constant is positive, that means your signs are going to be the same. But if it's negative, it means your signs are going to be different. Let's go put different right here for you. So when we're doing this, we're looking to be able to subtract to get to that 2, and that's an important distinction when we're doing problems like this. So the factors of 63 are 1 and 63, 3 and 21, 7 and 9. And that 7 and 9 is what we can combine to get a positive 2. And specifically, we would have to make it x plus 9. We made the bigger one positive, and x minus 7, and this is our answer. Same idea with the next one. Our sign in front of the constant is again negative, so it's going to be 2 different signs. We'll do our x factor where we have negative 6 on top and negative 27 at the bottom. So this will be 1 and 27 and 3 and 9, and I think that's it. So our combination would be the 3 and 9, and specifically this time we need to be able to add or subtract to get a negative 6. So I'm going to make the bigger number negative this time. So it'll say x minus 9, x plus 3, and that is our factored form. So doing a normal trinomial like this is pretty easy, but what if it's not a leading coefficient of 1? What if it's something different, like in the problem next to it, which says 3x squared plus 14x plus 15? Like, what do we do at that point? Well, in this particular method, I like to teach slide and divide. So what you're going to do is you're going to take that coefficient and you're going to slide to the end, and you're going to multiply. So it will now read as x squared plus 14x plus 45. And then we're going to factor like normal because it looks like normal now. So we're going to do the x factor where 14's on top, 45 is at the bottom. That'll give us 1 and 45, 3 and 15, 5 and 9. And at this point I can stop because I have the 2 numbers that I can add, because the number or the sign in front of our constant is positive, so we know we need to be adding. If I add 5 and 9, I'm going to get that 14, so I can rewrite this as x plus 5, x plus 9. All right, however, this particular method is not called slide and multiply. It is called slide and divide. And so far we have not yet divided. So once you're done doing your x factor, this is the moment you need to divide by whatever you moved. Originally we moved to 3, so we're going to divide each number by 3. If you end up with a fraction, you want to reduce as best as you can and then put your denominator in front. So 5 over 3 is already reduced, so I'm just going to make it 3x plus 5. But if you end up with a whole number, just, well, reduce. So 9 divided by 3 is 3. So my answer is 3x plus 5 times x plus 3. So I would strongly recommend next to the section writing that this is called slide and divide. All right, beneath that in example 3, all right, let's do 3.1a on the left. First things first, is there a GCF? Yes, there is. Please make sure you factor out your GCF. So we're going to factor out a GCF and we'll get x squared minus 2x minus 24. Then we'll do our x factor. Negative 2 and negative 24 are put in their corresponding locations. Notice that the sign in front of the 24 is negative, so we know we need to have two different signs for this, or we need to be subtracting. So this is going to be the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and I can see pretty quickly that my 4 and 6 is what I need to subtract and get a negative 2. Specifically, it's going to say x times x minus 6 times x plus 4, because negative 6 plus 4 gives me that negative 2. And just a quick note, make sure that if you factor out a GCF, you carry it with you all the way to the end. It's not just something you factor out to make your number smaller and more manageable. It's a part of the problem, so you can't just leave it off. So this becomes our final answer. Same idea with the one beneath it. It's the same idea. Factor out an r squared minus 8r plus 15. Do our x factor with the negative 8 on top, 15 on the bottom. So that gives us 1 and 15 and 3 and 5. Again, the sign in front of our c is positive. So that means we need to add. They are going to be the same sign. We need to add them together. So that's going to give me the 3 and 5 combination. And specifically, they should both be negative. And I made a mistake. I put positive. Shame on me. Let me change that really fast. This is going to be supposed to be a negative because they should both be the same sign. Should both be the same sign. And they're both negative. Okay, there we go. Now it's fixed. So then this becomes my answer. So off to the side, we have example 3.2, factor the polynomials. We have 2q to the fourth plus 9q cubed minus 18q squared. This is actually the same exact problem we had in 1.1, or actually 1.2a, where we just factored. But in this particular case, they want us to factor completely, not just the GCF. So if we were to just do that first step, right, the same way we did before, we would have q squared, and then inside the parentheses, we would have 2q squared plus 9q minus 18. All right, there is no number that goes into 2, 9, and 18. It just isn't going to work. So we're going to do the slide and divide method. Slide that over and multiply. We get q squared times q squared plus 9q minus 36. All right, now it's a normal trinomial. So we'll do our x factor with the 9 on top, negative 36 at the bottom, and we'll list the factors of 36. So there's a lot of more of these, but it should be okay. Notice that the sign in front of 36 is negative, so we have to subtract to get to that 9. And so our combination should be this 3 and 12. Specifically, I have a positive 9, so that means my larger number should also be positive. So it should be a q squared, q minus 3, q plus 12. All right, but remember, it's not called slide and multiply. It's called slide and divide. So you have to make sure you divide each number by whatever you moved, which was a 2 in this case. And if you end up with a fraction, reduce and put your denominator in front. So this will not say 3 over 2, but 2q minus 3. And then if you have a whole number, well, you just reduce. So this will be q plus 6. And that is our answer. Same idea for example 3.2b. We have, again, no GCF for the coefficient, but we do have a GCF for our variables. That'll be x squared, giving us 18. X squared plus 51x plus 8. Again, I cannot do anything with those numbers, so I'm going to do slide and divide. This will give me x squared times x squared plus 51x plus 144, which is a beautiful number. So we're going to do our x factor with 51 on top and a 144 at the bottom. And I think I was looking at a previous problem because I definitely put -8 right there. Shame on me. That's going to be a positive 51. So the factors of 144 are 1 and 144, 2 and 72, 3 and 48. And I could keep going, but I actually see my answer at this point. 3 plus 48 gives me that 51 that I'm looking for. Remember, I know that I'm going to be adding this time because the sign in front of my constant, which is 144, is positive. So I know I need to add to get to my values. So this is going to be 3 and 48, and they're both going to be positive to get me a positive 51. So I'm going to rewrite this. X squared times x plus 3, x plus 48. But remember, not slide and multiply, slide and divide. So let's divide by the 18 that we moved. All right. Unfortunately, when I plug this into my calculator, it's going to give me a bunch of decimals. So I know that my answer is unfortunately a whole bunch of fractions. So we need to reduce and then move the denominator. So when I reduce 3 over 18, that's going to give me x squared times x plus 1 over 6. And I'm going to move it in a second. So for right now, we're just going to reduce it. For the next one, I have 48 over 18. Well, that can both be divisible by 6. So that's going to give me 8 over 3. And then I'm going to move each denominator over. So now it's going to read x squared. Let's write this. X squared times 6x plus 1 times 3x plus 8. And that is my answer for the trinomial. So slide and divide is very helpful. It puts it in the format of a normal trinomial. Just make sure you divide, and when you get your fraction, be sure to reduce and then move. So then the last little bit of review for our section here is going to be our special products. So we have 3 main special products, and really, as long as you recognize these patterns, it's really just a shortcut. You can still get to any of your answers without doing this and by normal x factor, but it's just nice to know that there are some shortcuts out there. The only one that I don't believe any of you guys have seen before is the sum and difference of cubes, which is over here off to the right-hand side. So let's start with the difference of squares. First things first, please make sure that you understand you cannot do this if you have a plus sign. There is only one option, and that is if it is a minus sign. If you have a difference of squares, you become you take the square root of each one of these, so which we get a and b in this particular case, and you would make one positive like this, and then one negative like this. So in the example below, x squared minus 64, take the square root of each one, we get x and 8. Square root of 64 is 8. And so we need to write this as binomials where one is positive and one is negative. So it'll say x plus 8, x minus 8, and that is my answer. Beneath it, we have the same idea. In fact, we've started this one before. We need to factor out that 3p cubed to get p squared minus 64, and it's actually the exact same information that we have before. So we're going to say, okay, square root of the first, square root of the last, that gives us p and 8. So it should say 3p cubed, because remember, you always carry your GCF with you, times p plus 8 times p minus 8. And that's our answer. The one beneath it, we have some pretty high numbers. We have 49 and 100. I was going to say 81, but it's definitely not 81. It's definitely 100. We do not have a GCF, though. So for this one, we just have to ask ourselves, okay, well, what does this look like? And it actually is very similar to a difference of squares. So we're going to take the square root of 49a squared and the square root of 100. The square root of 49 is 7, and the square root of a squared is just a. So we're going to put those two together because they're together in the problem above. And the square root of 100 is 10. So our answer for this one, remember we need a positive case and a negative case, is going to be 7a plus 10, 7a minus 10. And that's our answer. Letter C. Actually, not letter C. We have to go over the perfect square trinomials, which is over here at the top, over here. In this particular section, this is actually something we've seen before. It is from chapter 3, I think it's 3-3, which is completing the square. And I remember teaching it to you guys, and I said, this is the one where you have to find the pattern, and if it follows the pattern, you can use the shortcut, which is taking the square root of the first, square root of the last, and the sign in the middle. So in this particular section, it should almost always work out to be a perfect square trinomial if you think it is, but just in case, we're going to take the square root of the last one right here, which gives us 4, and make sure that it does, in fact, if we multiply it by 2, does, in fact, follow the pattern, and it does. So we're taking the square root of the first, square root of the last, and the sign in the middle, because it does follow our pattern. So we're going to say it's x plus 4, and then the notes here say you just need to square it, so our answer will be squared. So in C, I'm not really sure which version of the notes you have, because it should be 36 right here. First thing we need to do is add 108 on both sides. So 108t on both sides, my bad. Again, there is no like terms for this one, so we're going to just tack it on at the end, since, we can't combine it with anything. Again, you could set it equal to 0 if you really want to, but you don't have to. Our GCF of this one should be 3t, which gives us t squared plus 12t plus 36. Okay, so before we do our shortcut, we have to make sure that we're allowed to do the shortcut by checking the pattern. So we're going to take the square root of 36, which is 6, and multiply it by 2. And it does, in fact, equal 12. So we know that this follows our pattern. If it was like 14 or 10 or anything besides 12, it would not follow the pattern, and we would have to do the x factor. But because it follows our pattern, we can do the shortcut. So we're going to take the square root of the first, square root of the last, and the sign in the middle. Carry down that GCF, 3t, and we're going to do the shortcut for that trinomial there to get t plus 6 squared. And that's our answer. So the last portion is example 4-2, and it's about your sum and difference of cubes. Now, if you're in honors, you're going to have to memorize this. But if you're in standard, you just have to know how to use it. You're not going to be really required to do this. So it might be like some extra credit, but other than that. But we have 2 formulas up here, and the formulas are very nice because they all follow the pattern SOAP. SOAP. It stands for whatever sign that you have right here, like in the top one, our sign is positive. It stands for, if you were to expand it, it's going to be the same sign, the opposite sign, and then the last one is always positive. So that's what it stands for. And we can see that the same thing happens for a difference of cubes as well. So to do this pattern, what I'm going to do is take the cube root of our x cubed here to get x, and the cube root of 8, which gives us 2. And we are going to plug it into our formula, which we see above. So we're going to say, all right, well, this is going to be my A, this is my B. So I'm going to plug it in. Here's the formula. I'm going to rewrite it really fast. There we go. So this is the formula. My X is going to go in place of all of my A's. So here, here, and here. And my 2 is going to go in place of all of my B's. Then I'm going to rewrite it and make it look pretty. So it's going to say X, we'll say X minus 2 times X squared. And X times 2 is 2X. So I'm going to rewrite that as 2X. And then 2 squared is going to be 4. So that's going to be 4. And this is my answer. Same idea below. Same concept, but now we're doing the sum of cubes. So I'm going to write that formula really fast so that we have it as a reference. The cube root of x is x. Cube root of 64 is 4. Please make sure you note that. A square root of 64 is 8, but a cube root of 64 is 4. Now that we have that, remember it represents our a and b, so we're going to plug it into those corresponding spots. A gets all the x's, and all the b's get 4s. Then we're going to rewrite it all pretty. It'll say x plus 4 times x squared minus 4x, and then 4 squared is going to give me 16. So that's going to be our answer. Even if we have a GCF, we can still do the same process. Our GCF for this one is 2, so I'm going to factor that out, and then I'm going to do the same process again. This will give me x, cube root of this will give me 5. This is a difference of cubes, so it should say 2x minus 5 times x squared plus 5x plus 25. Note that I carried my GCF down, okay? So don't just forget about it just because you don't like it, okay? That's rude. Last one, again, we have our GCF that we need to factor out. 3h to the 6th power is going to be our GCF. Factor that out, we get h squared minus 64. So if I take the cube root of that, it's h, and the cube root of 64 is, again, 4. I just really want to emphasize that. Plug it into the formula, carry your GCF as well. So that GCF is 3h cubed, 3h to the 6th power, not cubed, times h minus 4, because I'm plugging in an h now, times h squared plus 4h plus 16. And that is our answer. So the factoring is probably the biggest portion, but once we're done factoring, we can easily find the next piece of our information. So factoring is really nice. It helps us a lot, but it's usually used as a stepping stone to solving polynomials. And that's when, after you're done factoring, you set each part equal to 0, which is what this little line up here says. But we're gonna set each part equal to 0 and then get our solutions, okay? So, or our zeros, if you will. So in the example above, we have 2v to the 5th power equals 4v to the 3rd power. First things first, I need everything on the same side. So I'm going to subtract 4v cubed on both sides. It does not like terms, so they're going to sit next to each other. 2v to the 5th minus 4v cubed. Again, I could say equals 0, but it doesn't matter. I need to factor out my GCF, which is 2v cubed. That'll give me v squared minus 2. From here, I need to use the 0 product rule, which is take each piece and set it equal to 0. So my 2v cubed is going to be set equal to 0, and so is my other piece, but I'm going to do it in a second. To solve this, I would divide each side by 2. That gives me v cubed equals 0. And then I would take the cube root of this, and any cube root, fourth root, whatever, anything that takes the root of 0 is just 0. So that's going to be one of my zeros. And then for the next one, it's going to be v squared minus 2 is equal to 0. Add 2 on both sides, take the square root, and we get v equals positive or negative the square root of 2. And so our final answer is going to be v equals 0, comma, square root of 2, comma, negative square root of 2. Make that a little more obvious. And this is our answer. If you're in honors, you should probably know that the 0 has a multiplicity. Let's see if I can write it here. Hold on. It has a multiplicity of 3. I'm trying to write it. Hold on. It has multiplicity of 3. There we go. And that's it. So because in honors, we talk about how our highest exponent here, that's how many answers we should have. So I should have 5 answers. I have, if you will, 3 zeros, a positive square root of 2, and a negative square root of 2. So that's a total of 5 answers. So I know I did this correctly. All right, same idea. And in fact, all of these have been done before in example 5.1 and 5.2. They're all exactly the same as your previous examples from this section. So we could, factor all these out again, or you could just go through your notes and just write down what the factors are and then go from there. For me, I'm actually going to go through all the steps again because it's just good practice. But 5.1a it has 4 terms, so I know I need to do grouping, so I'm going to start off by cutting it in half. The first half, I need the GCF of that. That's going to be x squared. Divide that out to get x plus 2. GCF of the second half is a positive 3. Divide that out to get x plus 2 again. I know I did it correctly because my 2 parentheses are equal to each other. So I'm going to combine those, and the 2 pieces that left are going to create their own group. All right, so that's our factors. Now I'm setting each piece equal to 0. Once I'm done with that, I need to start solving them one at a time. So on the left-hand side, I have I can start off by subtracting 3. And then afterwards, I need to take the square root. But remember, when you take the square root of a negative, you end up with an I. And I can't do anything with the square root of 3, so it's just going to stay the square root of 3. And then for my x plus 2, I need to start off by subtracting 2 to get x equals negative 2. When you write your answers, please do me a favor and write it out, all of them. So this will be negative 2, comma, positive I times the square root of 3, and negative I times the square root of 3. So please make sure you're putting all of your answers as a list. It becomes important later, so for now, just indulge me. B, same idea. We need to factor out that x. We get x squared minus 2x minus 24. Factor that even more to get x minus 6, x plus 4. Set each piece, including the GCF, equal to 0. Each piece, including our parentheses. And then solve. The first one is already done. X equals 0, I can't do anything with that. It's just going to be x equals 0. I mean, like, I could multiply it by 1, but what's the use? So I'm going to move on, okay? I'm going to go to x minus 6, add 6 on both sides to get x equals positive 6. Same thing with that negative 4, or with that positive 4, it'll become x equals negative 4. So when I write my answers, it'll be x equals 0, comma, 6, and negative 4. Last one, my GCF of this is 3p cubed. That'll give me p squared minus 64. That's a difference of squares, so that's going to be p plus 8, p minus 8. Again, set each piece, including your GCF, to 0. So we're going to set all these equal to 0, and we're going to solve. I'll take the cube root of 0, which gives me 0. P plus 8 equals 0. Subtract that to get negative 8. P minus 8 equals 0. Add that to get a positive 8. So I'm going to write this all out. It'll be 0, negative 8, and 8. Remember, for honors class, we would have to include that there's multiplicity of 3 with that 0. And we know it's going to be a multiplicity of 3 as opposed to like a 4 or 5 because the exponent that was with it was a 3. So the final little bit is just basically a review of synthetic division because I just want to make sure nobody loses that skill. It's a really good skill to have. It says in this particular section, use synthetic division to determine if the following is a factor of the polynomial. And this next sentence is really important. Go ahead and just highlight it. But it should be, if the remainder is equal to 0, then it is a factor. But if the remainder does not equal 0, then it is not a factor. So sometimes it's hard to understand when you just read it. So let me show you. In the first example, we have our function and we have our factor x minus 4. Remember, in synthetic division, you need to flip this number. And technically, you're supposed to set it equal to 0 and solve. So that's how you get the positive 4. But then we're going to set up our line for synthetic division, and I'm going to carry down my coefficients. Before I start, I'm going to ask myself, do I need any placeholders? I have x cubed, x squared, x, and then my constant. I'm not missing anything, so the answer is no. I'm just going to carry down those coefficients. Okay, first things first, carry down that first number, which happens to be a 2, and multiply and put it underneath the next number. So 4 times 2 is 8. It goes under the 5. Add downwards to get 13. 4 times 13 is 52. Add downwards, we get a positive 15. 4 times 15 is 60. That equals 0. They do, in fact, cancel out. So we would write the sentence or the statement, x minus 4 is a factor because the remainder equals 0. Because the remainder equals 0. But unfortunately, that's not always going to happen. In our next example, it's definitely not the case. We have x plus 3 at the end, so we need to switch that to get negative 3. I'm going to put my little line here. I'm going to carry down my coefficients, 6, negative 15, negative 9, and I need to ask myself, do we need any placeholders? 100% I need my placeholders. I have x to the 5th, x to the 4th, and x to the 3rd. I'm missing to the second power, to the first power, and I'm missing my constant. So I actually need 3 placeholders in this particular case. All right, so now that I have my placeholders, I can go ahead and get started. And I'm actually going to include what these represent because it's just going to get, just to make sure that, we have the right number of placeholders. Carry down the 6 first. We get negative 3 times 6, which is negative 18. Add downwards. They're the same sign, so we get negative 33. And negative 33 times negative 3 gives me positive 99. add downwards to get a positive 90. Multiply that to get a negative 270. Add downwards to get, well, negative 270. Multiply again. We just keep getting higher and higher, but it's fine. It's fine. It'll be okay. Add downwards to get positive 810, and then multiply that 810 by negative 3. Don't worry, it's the last time. So that'll give us negative 2,430. Add that with 0 to get, well, negative 2,430. So obviously, we did not end up with 0. Nothing canceled out, which is super annoying, but it's okay. Now we can write our statement. We can say it's going to be x plus 3 is not a factor because the remainder is, well, you can write it one of two ways. You can say the remainder is negative 2,430, or it is not equal to 0. And that is our final answer. So there's a lot of things that we reviewed and learned in this particular section, but hopefully the fact that we spent a couple days on these items helped a lot. If you have any questions, please reach out to me, and you all should have my remind at this point.